Subscribe the channel and press the bell icon.
Hi my lovely students, how are you? This is Amit Ranjan Roy and today I am going to introduce what is Laplace transform and the reason of convergence. This is 3.1 lecture of signal and system, and after this lecture you can certainly answer following question, that is, what is Laplace transform, then what is the ROC, then what are the properties of the ROC, fourth one, what is poles and zeros, fifth one, that is the last one, how to find the Laplace transform and the ROC using the Laplace transform expression, and using the properties of ROC we will find out what is the ROC of a particular signal. So without wasting a time, please we will proceed. So what is Laplace transform? Laplace transform was generally introduced to represent continuous time signal in S domain. Okay, generally we are having three domains that are S domain, time domain, and we have frequency domain also, that we generally use to call J omega. Okay, so a Laplace transform is introduced to represent continuous time signal in S domain, that is, S is a complex variable. That means we have S equals to real plus imaginary part, that is J omega. Okay, and the concept of this system function for the continuous time LTI system is introduced. So what we have suppose y of t, this is the output, and we have a operator t, and we have a input, or we can say it Laplace factor, that is e to the power st. Now if we want to find out the Laplace transform, that is the h of s. What is h of s? That is Laplace transform of any signal, and h of s is what? Bilateral. That means from minus infinity to infinity. If you have unilateral system, that will be from 0 to infinity. And we have h of t. What is h of t? H of t is a impulse response, and we have the expression e to the power minus st dt. This is the Laplace transform. In general, we used to write it like this: x of s is equals to minus infinity to infinity, and then we have x of t e to the power minus st dt. Sorry, for frequency domain we generally refer it to be just omega. So ROC, the ROC is generally the range of value of s for which the Laplace transform converges. What does converge means? Converge means tends to infinity, tends to stability. What does stability refers? When a system have a bounded input and bounded output, as I have mentioned this in my earlier videos, you could understood that when the input is finite, then output should also finite. So the convergence means stability when it is a set of values for the s for which the Laplace transform tends to, or it approaches to the stability, that is known as ROC. For example, if you want to find out the ROC, then we will take one example. Suppose x of t is equals to e to the power minus a u of t. What does u of t means? U of t means unit step function. That means the value of u of t will be 1 from 0 to infinity. Okay, this is time and this is the u of t. So if you want to find out x of s for the above signal, So we have minus infinity to infinity. What we have? X of t e to the power minus st dt. We have formula. So when we put the value, so here minus infinity to infinity, as u of t is only belonging to 0 to infinity, so it will be converted into 0 to infinity, and minus infinity to 0, the value of u of t is 0, and anything multiplied by 0, it will give value 0. So we have neglected that value. So we have 0 to infinity x of t, we have e to the power minus a t. Here it is t. Okay, so we have e to the power minus st dt, and when we solve this, we will have e to the power minus, we will take common, s plus a t dt. It will be from 0 to infinity, and when we try to integrate this whole part will come in denominator. That means minus s plus a, and in numerator we will have e to the power minus s plus a. Okay, and this will be from 0 to infinity. Okay, and we have what we have value. After putting the value, we will get when we will put value of t equals to infinity, it will be e to the power minus infinity, and minus 1 by s plus a will be outside as a common, and we will have what, e to the power minus infinity minus e to the power 0. This will give value of 1, and this will be minus 1, and if we will keep it out, it will give plus, because this value is what, 0. E to the power minus infinity equals to 0, and e to the power infinity is equals to infinity. So we will have 1 by s plus a. Now what will be the ROC? Okay, since we can see that e to the power minus s a t, okay, this is the value, and when we are saying in denominator, this is same value, it's coming s plus a. So now we want that s plus a should not be equals to 0. Okay, that means it should be greater than 0. So the reason of convergence will be what, s plus a should be greater than what, 0. So we will have value what, reason of s will be, and when we will take this a to the right hand side, it will be minus a. So we have reason of convergence here, that is minus a. Reason of convergence is greater than minus a. Now when we are going to plot it, it will appear like this, where it is minus a is here, and we will do like this, and since it is greater than 0, that means we will plot it like this whole part. Got it? So simple. Okay, now moving ahead, suppose another question we will take, x of t is equals to minus e to the power minus at, and we have here u of minus t. That means we are having left sided signal. When we try to solve this, we will get x of s same 1 by s plus a, but here the reason of convergence, that means s is less than minus a, and when we plot this, then minus a is here, it will be plotted like this. Got it? This is real axis, and this is imaginary axis. Now moving ahead, what is poles and zeros? Simple. If we get a answer like this, x of s is equals to a naught sm plus a1 s m minus 1 plus a2 s m minus 2 and so on up to am, and it is divided by b naught sn plus b1 sn minus 1 plus b2 sn minus 2 and similarly plus bn. This numerator and denominator can be easily converted into simple form, that is a naught by b naught and s minus z s minus z1 up to s minus zm divided by s minus p1 dot dot s minus p2 pn. So what is this? This p1 is pole and z1 is 0. So you have to remember, after finding out the roots, the root in numerator will be equals to zeros and roots in denominator, that will be poles. Okay, now moving ahead and to what is ROC properties. So that explain that the ROC does not contain any pole. Okay, when we are plotting the ROC with real axis and we are plotting ROC with real axis and imaginary axis, we had not find that poles were in the ROC. We had mentioned that pole with dotted line and rest of the things were included. Okay, so first point or first property you have to remember, that is ROC does not contain any pole. Okay, moving towards second property, that is if x of t is a finite duration signal, then the ROC is entire plane. Okay, for example, for unit impulse function, that means if you are going to find out the Laplace transform of unit impulse function, that means for if you find it minus infinity to infinity unit impulse function e of st dt, will find that what is the Laplace transform? It will be 1. So the ROC will be all s. Okay, so moving ahead to the property number third, if x of t is a right sided signal, that means for example we have u of t is a right sided signal, that means 0 to infinity, then we have to remember that the value of t should be between finite duration, that means from positive to infinity. Okay, either it will be from 0 to infinity or 1 to infinity or 2 to infinity or 3 to infinity, like that, and the ROC will be what? Phi max. This is the pole, and what ROC we find out from the each signal, that ROC's maximum value will be included in right sided signal, while when we are going to left sided signal, then same condition we have u of minus t as an example, where it is going from 0 to minus infinity, or we can say it from minus infinity to 0 it is coming. So in that case we can see that for the ROC of different signal, we will include the region of S will be lesser than phi minimum. Same condition, phi is the pole of the each signal's Laplace transform. So coming towards the property number 5, if the x of t is a two-sided signal, then the region of S will be where it will be in between phi 1 and phi 2. Okay, this is for right sided signal and this one is for left sided signal. Okay, have you understood it? It is very simple. So now we will move toward solving numerical. So we have first question, we have to find the Laplace transform and their ROC, and we have first question, and we can see that u of t here it is and u of t here also. So it is an right sided signal. Okay, just before starting this lecture, we have learnt about e of a t e to the power minus at Laplace transform, and same expression we have here too. In a we have minus 2 and minus 3. We can get the Laplace transform of this signal as 1 by s plus 2, and for this signal we will get what? 1 by s plus 3. Okay, for ROC we know that the ROC for the right sided signal will be region of S will be greater than phi max, and we have pole here minus 3 and minus 2. Which one is maximum? Obviously minus 2. So the region of convergence will be minus 2. Okay, and if we add this both signal, this signal and this signal, we will get the Laplace transform of whole signal. So x of s will be equals to 1 by s plus 2 plus 1 by s plus 3. This will be equals to 2s plus 5 divided by s square plus how much? 5s plus 6. Okay, have you understood? And when we will plot its graph, this will be what? This will be real axis and this will be what? Imaginary axis. And we have what? ROC minus 2 here, and we will not include this. And as we know that region of convergence is greater than minus 2, so it will be like this. So simple, isn't it? So moving towards the next question. Next question is also same, but we have left sided signal, the left and we have no minus sign here. Okay, you have to remember that we have no minus sign here. So what will be the Laplace transform of this signal? This will be minus 1 by s plus 2, and this will be minus 1 by s plus 3. What will be the ROC of this? This will be minus 2, and this for this one it will be minus 3. And here we have to include region of convergence. For the left sided signal, it will be the minimum value of the pole, minimum value of the pole. So we have what minimum value? We have minimum value minus 3, so it will be minus 3. Now if we will add this, we will get x of s as minus 1 s by 2 minus s plus 3. When we will do this, we will have minus s minus 3 minus s minus 2 divided by s square plus 5s plus 6, and we have minus 2s minus 5 divided by s square plus 5s plus 6. And for the ROC, we can simply plot the graph. This will be real axis, this is imaginary axis, and we have -2 and we have -3 as a pole, and we have to include what? -3, and like this will be the region of convergence. Okay, plotting of region of convergence for this signal. So moving toward the next question, and this will be quite tricky, so we will solve this. Same question, we have to find the Laplace transform and the ROC of the signal e to the power minus a mod of t. That means when it is left sided signal, the value of t will be minus, and when it will be right sided signal, the value of t will be positive. Simple. When we will start doing integration, suppose what Laplace transform of x of t is equals to x of s, and we have minus infinity to infinity e to the power minus what a mod t e to the power minus st dt. When we will expand this, we have from minus infinity to 0, we have e to the power minus a, okay, and then that will multiply with minus t, okay, e to the power minus st dt, plus we will have from 0 to infinity e to the power minus a, t will be positive, e to the power minus st dt. Now what we will do, where it is minus infinity to 0, what e to the power, what we are going to do, we are going to keep what minus as common, okay, s minus a and t as common, and we have dt plus what we will have here from 0 to infinity e to the power minus as common s plus a t dt. What I have done here, we are multiplying this minus, we will have at, and here minus st, and we want to have positive coefficient of s, so we have taken minus as common here. So now what we will do, we will do t equals to minus t multiplication over here. Okay, so the timing will change from 0 to infinity, and we will have e to the power what s minus a t dt plus 0 to infinity same e to the power minus s plus a t dt. Got it? Now we can see here the region of convergence for this signal. For this signal, it is less than a, and for this signal we have region of convergence, what it is greater than what minus a. So when we will try to solve this, it will give us value like this. It will be 1 minus 1 by s minus a plus 1 by s plus a, and when we will solve this, we will get minus 2a divided by s square minus a square with ROC. Since it is left sided and right sided signal both, so we will have ROC, that is minus a is less than region of s is less than a. Got it? This was my whole lecture. In this lecture we have learned about Laplace transform, ROC, its property, how to solve it. Using property we can solve left sided signal, right sided signal, both sided signal, and we can find out the ROC and the Laplace transform very easily. For suppose we have a question like this: e to the power minus 80 u of t minus 1. That means this signal is starting from 1. Okay, so in integration we need to just change 1 to infinity. Okay, rest the procedure will be same. Hope you have understood this whole lecture, and if you have enjoyed watching this lecture, please like and subscribe to my channel. Thank you for watching.